Hi, I'm Dave here. So welcome to the third and hopefully the last part of the teardown and part savage of this poor little instrument. This was actually a Laben Spectrascope modular 8000. You know, because 1000 makes things important. By the way, this on the last part, I took all the boards out, and as you can see, it's actually empty on this side here. Was all the boards, and so the remaining parts today are the power supply section, and I'm gonna strip everything apart, like also the case. I'm gonna because I don't have space for it. I don't have space for anything here. Everything has to be compact and you know, modular kind of. You know, even if I have like huge oscilloscopes and huge instruments, and you know, even bigger bigger stuff, you know, power supplies, and apparently this rack is the heaviest thing ever. You know, it's actually something about 200 kilograms worth of power supplies. But anyways, I'm not talking about this today. I have to apologize for the last video because it was a little bit confused. You know, some parts were actually shot before and after. You know, it was kind of a mismatch of timing, you know, on the various clips. Let's get straight into it. So I have this thing, and geez, the thing that actually impresses me is that the metal work on this is just amazing. I mean, geez, look at that. That is solid. I think this is aluminum of some sort, or you know, or even metal. I cannot really judge right now. The fan is coming out right now, so that is quite a mess. But look at the all the gold pins here. That's just amazing. Those are all cottage connectors with the gold pins, gold connectors, full of stuff. And there is a original perf board modification here. That is fascinating. I mean, they added 2 transistors. I cannot really see those right now. Those are 2N708. And the date code is 94, apparently. Whoa, that is fascinating. Oh yeah, it's actually okay, so stuck right there. That's pretty okay. Yes, that should get. Oh man, that's good. That's good. Jesus Christ. Alright, so sorry for the handheld camera, but you know, I have no other way to show you this. So on the back here we have 2 huge transformers. So this should actually be a linear power supply, obviously, and we have series pass transistor regulation happening all over here. And look all the voltages we have. We have 7 voltages, 7 different voltages, and looks like we have some kind of a thermal protection right there. We have other boards here with a relay, and you know, oh, we have some main selections here. Have AC mains, and we only have, which is interesting, we only have 220 and 240, and 0, +5, and -5, -10. So here is the control board. Just a brief look at it, but the little resistor here with the wire wrapped around here. I don't know what's going on here, but they have 4 of those resistors. Those are 0.1 ohms. And I think those are some kind of a sense resistors. It's actually very elegant how the thermal design is actually made here. It's actually very cool. You have some air going out here that goes right to the actual boards, and there's some air that actually goes out here and on the back where all the actual power transistors are. So yeah, I mean, very, very nice thermal design. All right, that's pretty good. Yeah, I mean, all right, so this is the moment we have been waiting for, and this is the most interesting part and the most interesting board of the whole instrument. And it's the memory. So so this memory is a magnetic core memory, as you can see, and it's actually freaking huge for the thing. But you know, back in the days there was no, you know, flash memory or hard drive. So, and the best way to store something was to encode it on small tiny itty bitty beads that are made of ferrite that can actually magnetize. So you flip the polarity and you get a magnetic field around a little ferrite bead, and that ferrite bead stores one single bit of memory, so either a 0 or a 1. So I already removed the top part of it. Had to desolder all the little pads here, and I had to desolder also some wires to get it, you know, accessible and visible, because it's so nice. Look at that. That is a work of art. So this memory on this particular instrument, you know, it depends on the, at least from what I read, it depends on the actual ADC you have. You can have a larger or smaller memory. In this case, we have a 4096 channels ADC. So this memory here is a 4096 single bits of memory. So it can actually be subdivided by 1, 2, 4, and 8. You know, the 4096, you can actually say that, is in 4 bits mode. So divided by 4 is 1024 bytes of memory. So that is actually quite a lot. All right, so on the bottom side we have, ta-da, other those modules. I have no idea. Still, I have no idea what they are. I think those are just filters. Right, so as promised, we're gonna actually take a good look at this ADC, analog to digital converter. Alright, so here's the front of the standard NIM module here. As you can see, there are many knobs and whatnot. You know, everything is so good, but inside I think will actually be better. Alright, so voila, gold everywhere again. They actually divided the thing into many sections. So in the, probably in the service manual, you say, you know, section, for example, let's say here, section 1, C1, there is a operational amplifier right there. There is so much gold inside here. There's glare everywhere. I mean, I'm sorry, I cannot really, but look at the precision 10-turn knobs here. That is really quite nice. That is a linear plus and minus 0.25%. I mean, this thing would have cost a fortune back in the days. I'm pretty sure that in, let's say a day code here, 70, 71, in 1971, this was state-of-the-art technology and state-of-the-art construction. Look at all the cable looming there. That is fascinating. This is just crazy, and probably those were actually done by a machine here, but I mean, all the cabling here, all the soldering is all done by hand. So imagine just how many units. Oh man, my bet is pretty low number actually meant to be serviceable. And there we go, we have a metal screen here which hides something. So here's the other side, and whoa, that's more analog-y kind of stuff. We see some discrete stuff happening here all over the place, really. I mean, I have no idea on what this was, you know, the board, what it does. And you can actually see here, there are 3 boards in it. And the middle one has 2 shields and some funky wire to, you know, point-to-point wiring happening right there. I mean, geez, that is fascinating, and I really want to see this board here. So let me actually try and get this thing out. This little board that flips out like this, it's on little hinges. Look at that. Alright, so let's try this. So this is a lot more than I expected, and sorry for the glare, but we have some Motorola parts right there, some MC1027 P, and those are all, no, this is a 1018 P, and this is a 1017 P, 1018 again. So after all those custom parts, some Motorola parts right there, probably we have some regulation here. And look at those transistors here, those are actually flipped, and probably for, you know, making them contact with the actual aluminium on the bottom here to have some kind of a heat dissipation. And again, look at all these sections here. Alright, so at the end, the remaining parts, you know, I still have to remove the back panel here with all the nice switches and BNC connectors. But, you know, the rest is actually gonna be scrapped, unfortunately, because I don't have space and I don't have time, you know, to do something else with it. I actually found very useful parts for other things, like, you know, the CRT, a complete CRT system that I'm actually designing a little, I actually designed already a little power supply for it. That will actually power up the CRT, and I will actually have a very nice X and Y display. I actually tried to recover the gold from one board, so I, you know, desoldered everything from the board. I, you know, cut the board in smaller pieces, and I had created a solution of copper chloride. Why copper chloride? Because, you know, I wanted everything but the gold to be dissolved. There are various ways to dissolve gold. The, you know, most popular way and the better way, the best way to dissolve gold is by Aqua Regia. You actually make Aqua Regia with a solution of nitric acid and hydrochloric acid, and that is all fine, but it will actually, you know, dissolve everything with, you know, gold. Not only gold, but also copper and the other metals. And I didn't want that. I wanted just to dissolve everything but the gold. So the gold was still on the boards, and I scrap it away with a little X-Acto knife, and with that I can actually have a pretty pure gold. And then I, you know, obviously put the gold that I removed from the board in another copper chloride solution to dissolve the remaining copper or other metals that were present. And I had, you know, I've kind of filtered the gold particles off, but you know, there were tiny little particles, and I don't think I'm gonna do it for all the boards, because it was a heck of a job. It is quite a long, you know, thing to do, and you know, the plating is actually quite thick, but you know, the amount of gold there is, you know, I have more than 30 boards, so I'm pretty sure something like a gram of gold, it's probably there, but you know, doesn't really pay off for my time that I spent on trying to recover it. So I'm gonna actually keep the board as they are and try to recover some parts and frame all the boards. That's what I'm gonna do. So again, thanks for watching, and I'll see you next time. Bye.